Okay, let's start. Welcome to week 8. I hope the midterm was fine. I guess we had greedy problems and divide and conquer problems. So today we will move on to a different topic. I think currently in the class, Miles is teaching backtracking, and he just touched dynamic programming, I guess, towards the end of the lecture. But this homework, so the current homework, it will have some problems from dynamic programming. In this today's discussion session, we will see like how to solve those questions. Yeah. Yeah. So this session is the first one is gonna be taken by me, and the second session is going to be taken by Aditya. I think the homework is already there on Canvas. The deadline is moved to Thursday now, so please keep in mind it's not Friday anymore; it's Thursday midnight. So we have 3 problems. Yeah, it's less compared to the last homework. So I think in last homework we had 4 problems. So I hope this is fine. And please do sign up for the one-on-one sessions. Come to office hours if you are struggling with the homeworks or if you need help in understanding any course material. And as usual, feel free to ask any question on Piazza. So let's start dynamic programming. So to solve dynamic programming, actually there are some set of steps that you need to follow. So we will go through these steps. I think these steps are also mentioned in your homework PDF. There are around 5 to 7 steps that you have to follow. So for any problem, if you have identified that it can be solved using dynamic programming, then the first step is to find the set of related sub-problems. After you have found that thing, then you need to define your base cases. So you can have one base case as well, or you can have multiple base cases as well. We will see an example of both the things here today. After defining the base case, so basically you have a bigger problem. You divide it into sub problems, and eventually you will reach to the lowest level, and that will be your base case. So that's what I meant by base cases. And then you need to like define the recursion relation. So you need to do the analysis, and you need to like explain each sub problem that you have defined. And after that, after defining the sub problems, you need to mention like in which order do you solve these sub problems. So let's say it's an array, it's a 2D array, then you need to say like the x is moving from so and so, or y is moving from so and so, and based on that, like your sub problems will be defined. And then you return the value. So the output, the expected output that is asked in the question, you have to return that output. So there are 2 more steps sometimes. So it can be like, we can ask you to give a pseudocode. And if pseudocode is asked, then you also need to give the runtime. So if this is the case, it will be clearly mentioned in the problem. Yeah. So this is the set of 7 steps that we will go through. So let's try and then solve a problem first here. So yeah, so monster game returns. So you're playing a video game, and there are n levels in that video game from 1 to n. And at each level, you have a monster whose strength is defined by mi. And at each level, you will also have another variable called wi, which is basically like if you defeat that monster at that level, then these are the number of steps that you can skip. Okay? So yeah, you have n such levels. Each level has a monster with some specific strength, and you have another value w, which basically tells you like how many steps can you skip after defeating that particular monster. And the goal is to minimize the damage that you have taken. Oh, yeah. So the value h is basically, if you defeat that monster, the monster will have some specific strength, and in order to defeat that monster, you have to take that much damage here. So that's what h of I is here. Is it clear? We can also go over an example. Let's go over an example to like understand this problem set better. And as usual, the objective is to minimize the total damage that you can take. Okay. So if you are like defeated k monsters, the accumulation of the damage will be sum of all the h of i's at those particular k levels. So let's say an example so that it will be much clearer. So this is basically the W here is basically the number of levels that you can skip after defeating that particular monster. And this is the damage, the H is basically the damage that you can take. So this list here is nothing but the damage here. So you can see like this and this thing is exactly the same thing, okay? So let's see like how we can solve this problem. So let's say your solution set is 1 to 5 and 10. So that means like you are defeating this first monster first. And after defeating this monster, the damage that you can take, the damage that you will take right now is 4 here, okay? And the levels that you can skip from this point onwards is 3. So you can either choose this one, or this one. So it is saying that the next level that you have chosen is 2. So you are going to be here now. So you defeat this monster, and the damage that you will accumulate here is 3. The next is 5. So this one is the next level that you are going to. You also need to check if this is the right level for you. So you were at this point, so you could only skip like 4 levels now. So you need to just check if it is within the bound. 1, 2, 3, and 4. So yeah, this 5 index is basically within the bound. So at this point, you will accumulate a damage of 6. And the next, and the next index is 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So you reach at the last level, and the amount of damage you accumulate here is 8. So what is the sum of this thing here? 7 plus 6, 13 plus 8, 21. I hope the calculation is right. Okay, so you can see that the damage accumulated here is 21. So this is just an example. It might not be the case. It might be the case that this is not the optimal solution. Okay, so I hope this made it clear for you, like what this problem is asking you. Any questions here? Anything that is unclear? All good in the back? Okay, let's move on to the solution now. So I hope like you are used to this the specifications by now. So would anyone like to like take a guess like what are the instances here? Anyone? So what is the input basically? So like how do you define your input set here? So what are the values that is given to you? It is basically 2 arrays, right? One array is this H, and the another array is the levels that you can skip here. So these two values basically, and this W, the amount of levels that you can skip. So what is your solution set here? Maybe you can take like 15 seconds to like think about it. So how would your solution set look like? So in this example, you can see like the solution set are basically the indices, right? Yeah. So here your solution set will look something like this. So let's say it is a P, and you will have like something like Pi, P1, P2 till Pk. So we are basically saying like we are defeating K monsters. Okay. Yeah. So this one is interesting. So what are the constraints here? So like if you go from level Pi to level Pi plus 1, what is the constraint? Like how is this thing constrained by this instances that is given to you? Yeah?
That difference should be less than or equal to W of Pi.
Exactly, yeah, you're right. So it should be like P of I minus P of I plus 1, it should be less than equal to W of I, right? This is what you're saying. Yeah, this is correct. And what is the objective function here in terms of P of I's? Yeah, anyone? Yeah.
The cardinality of
Okay. You're saying K. Yeah, yeah. So actually you need to minimize the damage that you are accumulating here.
the sum.
Yeah, exactly. So sum of H of K's, H of Pi's, yeah. So it will look something like this. Sum of h of p of I is moving from 1 to k. Does this look correct? Any questions here? I hope this is clear. Yeah. So let's now see like how the recursion looks like. So this is the recursion tree basically that you will have to solve here. So what we are doing here, we are going to start from the last index here. Okay. So what I'm saying, so my subproblem is, so my problem is basically I'm saying, if I want to reach this level 5, how much damage am I gonna take? So this damage is what you want to calculate, the minimum damage that you can take. Okay. So if you are at the last level and you decide to defeat that monster, then what is the damage that you can take? It will be that particular level, right? So at this level you have 2 here. So it will be 2 plus something, right? At this level. Yeah. So now you have to think, in order to reach this level 5, like how can you reach level 5? So you definitely have to move from some previous level to that level 5. So you actually check here. So can you move from this level 4 to level 5? What do you think? It's 1. So it should be able to move, right? So this is correct. What about this level? Can you go from this to level 5? Level 3 to level 5? You cannot go, right? Because it only allows you to move one level up, right? So the max you can reach from level 3 is level 4. What about level 2? Can you go from level 2 to level 5? Its value is 3, right? So you can make a jump of 3 here. So 1, 2 and 3 and you can reach level 5. So this level is also correct. What about level 2? Sorry, level 1, which has the maximum jump value of 2. So in this case, the maximum that you can skip here is 3 and 1. So the maximum level that you can skip and go to is the 3rd level. So you cannot, so this is also not correct. So it turns out like you only have like this thing and this thing. I mean 3rd and 4th level that you can, sorry, 2nd and 4th level that you can go to. So that's where our, yeah. Yeah, so that's an interesting question. Actually, you can do both the ways. So this is what I choose to be like top-down approach. So the approach that you are saying, like if you start from level 1 and go to level n, that is a bottom to top approach. So that one is also correct, but like I felt like this one is more intuitive for me. So is it clear? So yeah, so we saw like to reach level 5, you can only go from level 2 and level 4. So you can see like the recursion, in the recursion the next levels are level 4 and level 2. This is clear, right? And the amount of damage that you can accumulate here at this level, particular levels, it's nothing but, let me make it clear here. So if you are at level 4, so amount of damage for level 4 is basically 4 only. So that's how this value comes from here. For level 2, the damage value is 3. So you have 3 here. Okay. So for each level, you keep on checking like what are the different levels that you can that can like allow you to reach that particular level based on your WIs and HIs. So whatever level you choose, you just add the particular H value there. Okay. So yeah, eventually you will reach these levels L1, 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 and the damage value that you can take at L1 is 2. So that's why this 2 is here. Is this recursion clear? Like, does it make sense, or you need some more clarification here? Okay. So like, there's some interesting thing to observe here. So if you look at it, you can see like there are a lot of instances that are repeated here, right? So if you look at this level 1, it has been repeated 4 times, right? So every time you do a recursion, you are repeating these levels. Similarly, level 2 is repeated 3 times. So you are doing like a lot of extra work. So in this DP problems, the task is basically to observe and see like what are the patterns or what are the subproblems that you can actually minimize so that you don't keep solving those same problems again and again. Okay. So, so this is the recursion tree, and there's one more interesting thing, like how do you actually calculate the whole value here? So if you have this recursion tree, and if you, let's say you choose to go through this way, okay, this is how you decided to beat your game. So what will be your total damage in this case? It will be the sum of all the h values, right? The d values, right? That is the damage that you are taking at each level. So for this level, it will be something like 2 plus 4 plus 1 plus 3 plus 2. Is it clear for this particular level? Similarly, like if you choose to go this way, then it will be 2 plus 3 plus 2. Make sense? Yeah. So yeah, so after looking at the recursion tree, you can see like at each recursion level, we are just interested to know like what is the maximum value or the minimum value you need to reach at that particular level, right? So like we were at, so we were at this level 5, but we are interested to see like how you can go from level 4 and level 2 to level 5. So at each sub problem, we are just interested to see what is the exact value for that particular level, right? So your subproblems can be defined like this. So let's say you are at kth level and you want to know what is the minimum damage that you can take to reach that particular level, k. So this is our subproblem. And how do you define the base case? So what do you think the base case is going to be in this case? So like you are going from level n to level n minus 1 or whatever the levels are, and eventually you will reach some base case. So what is that base case going to look like? Yeah? Yeah, k equals to, it will be k equal to 1. Yeah. So in that case, you only have one option, right? Because you are at the lowest level, you cannot choose anything else. So you have to take that. You have to beat that monster right there. So, so our base case will be m of 1 here. Is it clear? Yeah. Yeah, and m of 1 is nothing but h of 1, right? This is the damage that you are taking here. Okay. Yeah. So what is your recurrence relation? So now you are able to create the subproblems. So like how is your subproblem going to give you the answer for your that main set that you are trying to solve? So in this example, it looks something like this. At level 4, you take a damage of 0.10. You can go from level 1, level 2, and level 3 to that particular level 4. So what do you think the value is going to be for level 4 here? These are the base cases. So there is no level below this point. So what is it going to be for level 4? Yeah? Anyone? We are trying to minimize here, remember? Yeah. 14. Can you explain that? Yeah, exactly. That's correct. So here it is 4, here it is 7, it is 11. So as per you, you will take the minimum of that particular subproblems. So it will be 4 here. I mean 10 plus 4, right? Right? Yeah. So this is something that comes from the minimum of the subproblems. Is it clear here? Like how the recurrence relation look like? Or do you want me to explain it further? Like in this case, we are trying to minimize, but if we are trying to maximize, then instead of min, we will just do a max of that thing. So in case of maximization, it will look something like, we will choose this 11 instead. And this L4 value, it will look something like 10 plus 11. Got it? Yeah. Oh yeah, that's the trickiest part of this whole thing. Here, okay. This question, right? So so my thumb up rule is basically You try to solve, like in every problem it will be given like find the maximum value or the minimum value or the count of something something. So you know, like for the given input from 1 to n, you need to solve something. So I will always look like how can I divide that particular array or particular problem into different subproblems. So that's the trickiest part here. So here you come to know, like eventually you are going to reach at level n, right? Eventually you are going to reach at last level. So how can you reach that particular last level? So you keep on scanning the whole list now, and you see like that this particular index can take you to level 5 or the level n, something like that. And that's how like you think like in subproblems. So eventually you will reach a level before that. So now you ask yourself, how can I reach this level now? So actually you have to think in terms of recursion here. So if you are able to come up with a recursion, then that makes it a bit easier. But easier said than done. You still need a practice for this one. So like we will share some of the uh, practice problems for this homework, and that will make it even clearer. Okay. Yeah. So you can see like in our array we have 5 elements, right? In both the arrays we have 5 elements, and each index is basically that particular level. So so the maximum index is 5, and that is the maximum level that we are trying to reach here. Yeah. So like the maximum level is 5 here, and you definitely have to beat that monster there, right? So once you reach level 5, you have to beat that monster there. So whatever monsters you defeated before, you have to add 2 to that. So right now we know that 2 is definitely going to be there, but the rest of the term we don't know. So we just put a question mark there, and that question mark is solved by the branches that comes below it. Okay. Anything else? Yeah.
So for every level, essentially, you want to figure out the point from which you can get to that level.
Exactly.
So that you like just ideally do it, or do you like, somehow modify it to do it in constant time?
Oh, that's a great question. We will go there in runtime, but that question is valid. So in worst case scenario, what can happen is it can turn out like you can go from any level to that particular level 5. So right now it is 2, 3, 1, 1, 1, right? But I can make it something like 4, 3, 2, 1. So in that case, every level is reachable from that 5, right? Like,
So you have to check.
yeah. So in worst case scenario, you have to check everything before that particular point. So right now we are just seeing branching of 2, but in worst case scenario, it can be like there can be 5 sub problems for each problem, right? Anything else? Yeah. So let's move forward. I hope that solved your doubt, like how you think about the sub problems. But for each problem, it's basically a different thing. So, but the idea behind it remains same. Okay, the main idea. So like as we discussed here, uh, if you want to, so if you are at particular level, you take the minimum of all the things that you can, like all the levels that you can reach from there. Okay. So the case 1 can be you check for level 1. Case 2 is you check for level 2. So if you check for level 1, it is nothing but m of 1. So this is total damage so far, right? So this is the damage that you took to reach that level 1 so far, and you are making a jump to that kth level. So once you reach that kth level, you have to defeat that particular monster, the kth monster. So it will be plus h of k. Sorry, h of 1, because it is no right, it is k, because you are reaching that particular case, right? Similarly for case 2, let's say you decide to jump from level 2 here. So it will be total damage accumulated at level 2 plus h of k. So you check it for all I less than equal to k minus 1 here. So this is your k minus 1th. So like if we generalize it, it will be m of I plus h of k for every I less than equal to k minus 1 greater than equal to 1. Is it clear? It's basically a loop. Yeah. But there's one more thing that you need to check. For every I, you need to check that the constraints are right here. So in this case, you need to check this thing, that I plus wi. Yeah, so I plus wi should be greater than or equal to k. So because you are going from ith level to kth level, yeah, and the value here is w of I. So the maximum distance that you can cover from this point onwards is I plus w of I. So this k has to be within the range. So it should be, so k should be less than or equal to I plus w of I. Is it clear? Any questions here? Yeah. So yeah, so this is essentially the same thing that we just discussed. So m of k is basically h of k plus minimum of uh, all the levels that you can, like, you can go from that level to that particular kth level. You check it for all I less than or equal to k minus 1, and you also check if the constraint is right there. Okay. So the next question to ask is, like, what is the order that you solve this problem in? So like, how do you solve it? So what do you think, like, what is going to be the order now? Wait, let me show the tree again, and I think that will make it clear. So when we are at level 5, we know the damage that you are going to take at level 5, but we don't know the rest of the part, right? This is still question mark. So at which level this question mark won't be there? So that is the base case for you. So that is the first thing that you need to solve, right? Because there is no uncertainty. So what is going to be the first problem that you solve, like, eventually? It's going through the base cases, right? Because in base cases you don't have any certainty. Like in this one, in this case, there is no question mark here. You for sure know, like, the damage to reach that particular level is always going to be 2. There is no uncertainty there. So even though your recursion is going from top to bottom, the order in which you solve your subproblems is bottom to top. Is it clear? Like, first you solve this one, and then you solve this one, because once you solve this one, this is nothing but 3 plus 2. Yeah? Is it clear? So this is what it is saying. So we are solving from 1 to n. We solve the base case first, and then we go level up until we reach level n. And your output is nothing but the damage you took for the last level. Is it clear? Okay, great. Please feel free to interrupt me if anything is unclear, if anything doesn't make sense. Yeah. So this is the pseudocode. So this is the base case that you have here, and you also need to define your array here. So since you are taking the minimum of each subproblems, you need to define the current value as infinity, right? Otherwise, if it is any less than that, then it will mess up the whole equation. So by default, every level will have infinite value, like the infinite damage that you can take. Okay. So for base case, it is now h of 1, and then you run a loop for each level from 1 to n, and you find the m of k for that particular level. And you can see, like, there is another loop here running here over all I plus wi greater than or equal to k. So essentially there are 2 loops. So once you are at nth level, you will find the value of m of n, and you eventually return that. Any question in this one? Is it clear? Okay. Yeah, so what is the run time of this one? Anyone wants to take a attempt at this? So what are the number of sub-problems gonna be? So if you remember, we defined a sub-problem as m of k. So the amount of damage it takes to defeat, it takes to reach level k. So like how many k can you have here? Anyone? Yeah. N minus 1. Yeah, so you are assuming like for level 1 it's always going to be the same value, right? So yeah, so we can say it's of the order of n. Yeah. And what about the sub problems? So for every m of k, what is the time that you're going to take in worst case scenario? Yeah. Anyone? Yeah. Yeah, again, right. For every k, you have to check from 1 to k minus 1, right? So in its linear time again. And what is the overhead of constructing the initial array? So like in the first step, we define everything to infinity, so it's going to be linear again, right? So, so the overall runtime looks something like this. Number of sub problems multiplied by time it takes to solve each sub problem plus overhead. It's nothing but O of n square. Is it clear? Okay. Yeah, bonus question. Do we have time for this? Okay. So now that you found this minimum value, how can you actually get the exact path that you need to follow to get that minimum value? Yeah, anyone? Yeah.
Like similar to what we did for graph, have like a free index is stored, and the free index of the array is stored. We choose from where we got that value.
Yeah.
But we can trace that.
Exactly, that makes sense. So if you are at kth level, you check like what are the sub problems and which sub problems you are going to choose the minimum value, and basically you reach that level from that particular minimum value, right? Essentially, it is exactly the right answer that we are going to do here. So we are going to use a array p here, which is going to backtrack the whole thing here. So only this addition is there, like these two, like you define array here and then you perform some steps here. So p of k is nothing but I, and I is operand from the previous step. So basically it means the value of I for which you got the minimum value here. Okay. So like these are the small tweaks that you can see in the problems. Like there can sub problem, A problem can be find the recursion, B problem can be give the runtime, and C problem will be, so how do you find the paths, something like that. Okay. So like once you know the exact recursion, you can actually find the number of the way that you can go from level 1 to level n. Do we have time for second question? Yeah. So till now, any questions? Anything that isn't clear? So let's go on to the next problem. So this problem is called electoral college. So elections are going on, and each state has some specific number of votes depending on the population. Like if they have more population, the value will be more, yeah, something like that. And there are two presidential candidates that they are going to vote for, and each state will cast all their vote to one specific candidate. Okay, so like each state has some number of k number of votes that they can give, but the constraint here is that each state will only give their votes to a specific candidate. Okay, so this is the first constraint here. Each state will cast all their votes to one of them, and after all the votes are cast, the winner candidate is the candidate that has the most EVs. So yeah, the one with the most vote one wins. Okay, so this is the question, and if the candidates have same number of votes, then there is a tie there. And there is one more constraint here. It says the total number of EVs for all the state is even. So like if state 1 has 1, state 2 has 2, state 3 has 3, so the sum of these things should always be equals to an even number. So percentage 2 should be equal to 0. Okay, this is what it is. Like if you add up all the states, their votes, it should be an even number. Okay. Yeah. So your question is you have to design an algorithm which can find the number of ways in which these candidates can tie. Is it clear? Any questions? Okay, so let's see like how we can solve this. But before that, let's see an example here. So if you are given 4 states, total EVs are 8. These are the state EV values. So what are the number of ways in which you can actually tie? So the first case here is A can win state 1 and 4, and B can win state 2 and 3. So total votes for B is nothing but this plus this, 3 plus 1, and total vote for A is 2 plus 2. Solve for. So they are tying there. And similarly, the mirror case of that, instead of winning state 1 and 4, you win state 2 and 3 here. Yeah, and B will win state 1 and 4. Is it clear? So total number of ways is 2 here. So like if you rephrase this problem, we can like simplify the problem like what it is actually trying to ask. So there are m states and n votes, and we know that this n is always a even number. So the number of ways a candidate A to get n by 2 and yeah. So think it like this. So if candidate A gets x votes, the number of votes that candidate B can get is always going to be less n by x, right? So if you assign something to candidate A, candidate B is always going to get some default value, right? It's always going to be A minus x. So in both the cases, you only need x. Yeah. So the subproblem can be, instead of solving for both of them, we can just solve for one of the candidates. Yeah. And if they are going to tie, then this x should be nothing but n by 2. Make sense? Yeah. So we are only going to see like how many ways can we assign n by 2 votes to A, because if you assign n by 2 votes to A, B is also going to get n by 2. Yeah. Make sense? Okay. So this is the recursion tree, and it's a bit interesting. So again here we start with n by 2, and the states that that can vote for you is 1 to m, like the whole bunch of available states that it can vote for you. So this is the main problem that you are trying to solve. So this is how like you think about recursion here. So now you want to assign n by 2 votes. So how can you like? So you are at this junction here. You are at this state m. So this m state, it can either vote for A or it can vote for B, right? So if it votes for A, that means the required number of votes is minimized now by E of m, because this E of m votes are going for this particular candidate A. So it will be nothing but n by 2 minus E of m. Yeah. So in this case, the state m is voting for this candidate, but there can be other case as well. In that case, it votes to someone else, the other candidate. So in this case, the value remains same. It remains n by 2. So now the subproblem here is like you have already decided upon the votes for m, right? The mth state. So in the subproblem, you only check from 1 to m minus 1. Make sense? This thing, like how this array size is decreasing here now, right? Initially it was 1 to m, now it is 1 to m minus 1, and the value of required vote has also decreased. Similarly, if you go a level below here, you can see like now in this case the state m minus 1 is also voting for A, so the required number of votes is decreasing further in this case, and the number of states are also going to be like 1 less than the previous step. So here it was 1 to m minus 1, now it is 1 to m minus 2. Make sense, this thing? So like can anyone point out like what is the difference in the subproblems here? Like what is the difference that you see here compared to the last problem? In last problem we only had something like m of k. So does this look different to you, this thing? So what are the values that are changing here? The number of required votes, one thing, and the second is your array size. It starts from 1 to m, now it is 1 to m minus 1, right? So like intuitively, does it make sense? Like one D array won't be sufficient anymore for this problem, right? You cannot just find some array of required number of votes because that's not the sub problem. You also need to keep track of your states that can actually vote for you, right? So you need a 2D array for this one. Make sense? Why you need a 2D array for this one? Because you have two dependent variables now. Okay? Yeah. And eventually you will reach some base case here. So what do you think the base case is going to be in this case? So in the base case, before base case, let's discuss about the number of sub problems that you can have. So if you do something like this, for each state you will have two sub problems, right? For each problem you have two sub problems. It's like a balanced binary tree if you look at it, right? It's a perfect balanced tree here. So the number of states here is equal to 2 raised to m. If you don't do any kind of dynamic programming, you just do a simple recursion. But if you think about it, the number of subproblems, it cannot be more than m by 2. Because like you have a tree of size m, of height m, and each thing can have like n by 2 votes at max. So if you multiply everything, add up everything, it will be m multiplied by n by 2, mn by 2. That's how you get this value, right? So logically speaking, the number of states should not be more than nm by 2. So we are definitely doing something redundant here. So let's see how we can resolve that. Any question that before that? Yeah. This one?
Yeah, so I mean, instead of starting from anywhere to
Mm-hmm.
could it potentially also start from, let's say, 0 volts and then do last
So you start from 0 votes, okay? Yeah, you can do that. You can potentially. No, it's a choice actually. You can start from 0 as well. But in that case, like if you start from 0, then you have to say like if I, so when you have 1 to m, so at this point you can either choose to get vote from that one or you choose like it won't vote for you, right? So at this point it will be m, e of m for you because you are just adding up. Instead of decreasing, you are adding, you are subtracting, right? No, instead of subtracting, you are adding, right? So it will be e of m. That is also right. Yeah. So eventually it will be like e of m plus e of m minus 1, or it remains e of m for the next sub problem. So that is a choice that you can make. But based on this, your base case will change. Right? In base case, right now I'm looking for like value should be 0. Right? The required number of votes to get n by 2 is 0 in the base case. But in your case, it will be exactly n by 2. So it's the same question that that was asked earlier. Like instead of top to bottom, if you go from bottom to top, how things change. So it's valid to do that, but just be careful with the constraints and the base cases. Okay. Yeah. Any other question? Okay. I'm not sure if I have enough time to cover this thing now. How many more slides do we have? Or maybe we can cover it. Okay, I went too far here. Okay. So yeah, so right now, so subproblems can be defined as a 2D array, which is basically T of ij. So I is telling you to like the states that you can choose from. So if it is I, the states that you can choose is 1 to I, and j is the number of votes that is still pending to get n by 2. Okay, that particular j. So this is the subproblem that we're defining as. In your case, it will be a bit different, right? In your case, it will be T of ij will be, so instead of subtracting, you're adding here. So I is still the same. Okay, you're basically saying 1 to I is the state that you are choosing, but j is the total votes that you have got in your case, right? Make sense? But in this case, we are saying it is the number of votes that you still need to get. Yeah. Is this clear? Okay. So yeah, so there are two cases. Yeah. So here first one will be there are no votes. So it will look something like this. If there are no votes, then you will have some states, but the next value is 0 here. So if there are no votes, what will it look like? What is the value of this thing? Anyone wants to take a guess? So I'm basically saying you still have states, but you don't want to get any votes from them. So what are the number of ways in which you can do that? It's going to be 1, right? Everyone vote for the other guy, you get 0 automatically. There are no other permutation and combination in this case. So it's going to be 1 here. Is it clear? And in this case, what you are saying that the total number of states are 0 and you still have some votes that you need to accumulate here. So in this case, what is the value? So you have no states. So can you accumulate I votes? There is no other way, right? There is no way possible that you can do that. So it's going to be 0. So like I always like imagine it like a 2D array here. Like this might help you. So what I'm saying is, if I fix the row here, these values will always be 1, 1, 1, 1, 1. And if I fix the column here, these values are going to be 0, 0, 0, 0, 0. Is it clear? Yeah. Sorry, I couldn't hear you. I can change that variable. Yeah, it should be j. So I'm just saying like it can be any value I or j, but the number of states are 0. You don't have any state, but you still need some votes. Okay. I think I should change it to j here. So exactly the same thing that we discussed. So yeah, these are the ranges for that. Is everyone clear with the base cases, or you have still some doubt? All good? Okay. So the recurrence relation, it will look something like this. So you need 4 votes, you have 4 states. How can you solve that? You go one level below, you have 3 states now, you reduce it by 1 and you decide for the level, for 4th level. You can either make it vote for you or it won't vote for you. So in this case it votes for you. So the required number of votes now is 4 minus 2, and in this case it still remains the same. Make sense, this thing? Yeah. So the code will look something like this. So you will have 2 variables and you find the value of Tij and you add these 2 subproblems in this case. So in this case we don't have anything like min or max. You just have to accumulate everything, like the total number of ways in which you can like make a tie there. So you simply add here. So this is the operator that is there we are using here. Okay. So it is similarly like this thing. So if it is Tij, so these 2 subproblems will be T of I minus 1, j minus m of j, or it is the other value in which you don't decide to vote for it. You don't decide it to vote for you, so it will still remain the same. Okay, and to get this value, it will nothing but addition of these 2 things. Clear? Make sense? Okay. And there is one more constraint as well. So this value, it cannot be less than 0. So you need to make sure like j minus e of I, it is greater than or equal to 0. So it turns out like j is greater than e of I. So the variables here it doesn't look right. So it should be j should be greater than e of I. Okay. So if it is greater than 0, then your a is 1. If it is less than 0, then your a is 0. Then you don't add that thing. Make sense? Because you don't want to get don't want your required number of votes to be negative, right? it always has to be positive or 0. Okay, clear? Yeah. So what is the order in which you solve these problems? So we saw, like, in order to solve this ij, we are going to I minus 1 j, or we are going I minus 1 j minus m of j, right? These are the only two things that we are solving here, right? So you either go upwards or you go towards left side. So this is the 0 comma 0. So you solve your I from 1 to m, and you solve your j from 1 to n. So from left to right. Okay. So in order to find this value, you fill up this area here. Make sense? Make sense? So this is the order that you have to define it as. And output is nothing but m n by 2. It is basically saying you have m states, you need to get n by 2 votes. Yeah. So the number of subproblems will be, what do you think the number of subproblems are going to be in this case? It's going to be nm, right? Because you have two loops. So n into m, and this is O of 1, this is O of nm. If you add up everything, it will be O of nm. Okay. This is it. This fun fact, but I'm not sure if we have time for this, but I will just take 1 more minute of yours. So it turns out, like in the previous elections, the number of ways in which you could have a tie is 16 trillion. So one would think like it's very difficult to get a tie, but it's such a huge number. So you can imagine, like, the number of ways in which you don't get a tie is even bigger than this. Yeah. So thank you for showing up, guys, and all the best for your homeworks. Here for like a couple of minutes. If you have any question from the homework or anything like that, from previous homework or anything like that, I will be happy to help you.